Hello students, this is lesson U5A02d. By the end of the lesson, you should be able to say I can find the coordinates of a point that divides a line segment into specified proportions. Now this topic is actually very unique to Regents classes, and unfortunately, I hate to say this, but I'm making this video solely because this question for this topic, a question of this topic, comes up all the time in every geometry Regents that I've come across. So let's take a look. Okay, so point B divides a line segment AC into a proportion of AB to BC having proportion of 2 to 1. Find the coordinates of point B if coordinate A has coordinates of 1, 2, and C has coordinates of 7, 5. What are we going to do to figure this out? I encourage you to pause the video and give this a try before I go over this. So hopefully you guys had some time to think about this. Let's take a look at some of the strategies that we can adopt. Now, for speaking for myself, whenever I'm given coordinates or anything that's graphical, it is recommended that you do try to plot this on a grid so that you can see what's happening. So if you notice right now, I don't have a I don't have a coordinate grid, okay, per se, but I did manage to draw something resembling that, right? And this should be a strategy as well. Sometimes you're not always going to have graph paper. However, just drawing something on a sheet of paper can definitely help with the problem-solving process. So the strategy is, okay, right now I'm trying to figure out a point on the line segment that will divide this line segment into 2, 1. I mean, not into 2, 1, into proportions of 2 to 1. So in other words, the point that I'm looking for is going to be somewhere over here, closer to point C than it is closer to point A, because AB is supposed to be longer than BC, right? So the length of AB is supposed to be twice as long as BC. The only thing is, we're not looking for the length of what AB and BC is. That would be too easy, okay? Because all we have to do is find out what the length of AC is and then figure out what the correct proportion is. The question isn't asking that. The question is asking for the coordinate that will create that proportion. So the strategy, actually, okay, is even though we're working with a line, and this line is drawn on a coordinate grid, it is possible for us to construct other geometric relationships from this. I can actually form a right triangle out of this. And having this right triangle drawn, we can then recognize if we were to identify this point here, B, right? AB, the length of AB should be 2/3 of the entire length AC, right? That's another way of looking at it. The length of AB should be 2/3 the length of AC. And wait a minute, if I were to then draw a line from point B down to the horizontal there, can you guys recognize that we are actually dealing with two right triangles here that are overlapping one another? And this is actually a diagram that we've been working on for the past lesson, right? So if this is the case where we have two triangles that are similar, that are overlapping one another, that means all of the corresponding parts of the similar triangles will be proportional. That's right. Corresponding parts of similar triangles will be proportional. So how are we going to use that to our advantage? Well, I understand that that this proportion can be set up. That AB to AC, which is 2 to 3, right, is AB to AC, is also going to be true for AD to AE. Again, this length here. This shorter, smaller leg is going to be 2/3 that of the longer leg, right? Just like the hypotenuse, AB is going to be 2/3 of the longer hypotenuse, Okay, similarly, BD to CE will also share the same proportion. So recognizing this, okay, that they all will share a proportion of 2/3, I can then easily establish, well, knowing that this length right here is 6 and this length is 3 because I just found the change in y and change in x, I can then say, oh, wait a minute, I can then set up the proportion. Oh, AD to AE should be 2/3. And I know what the length of AE is. AE is 6. So therefore I can say AD is 2/3 of AE, which is going to be 4. Similarly, I can solve for what BD is by saying BD to CE is again equal to 2/3. And I know what CE is. CE is equal to CE is equal to 3, thereby giving me BD is equal to 2. Now, these are not coordinates. 4 and 2 are not coordinates. So AD is 4, which means we're going to go 4 to the right from point A and 2 up, okay, from point A, which leaves us with coordinate B as 5, 4. So we're going to try to adopt the same strategy for the next problem. I encourage you to, again, pause the video to try this out on your own. Having gone through that last problem, reviewed that last problem, I encourage you to try this out. So the strategy, okay, is very, very similar. What we're going to try and do is we're going to create triangles out of this, right triangles out of this. So we're going to construct that. We're looking for a point between x and z, point y that is, so that we create a proportion of 3 to 2. Well, seeing this right now, I see that we have 2 overlapping right triangles. The length of YZ compared to the overall length of XZ, YZ and XZ are actually hypotenuses, okay, of the 2 right triangles there. The proportion of the lengths of the hypotenuse between the smaller right triangle and the larger right triangle will be 2 to 5, or 2/5. So if that's the case, then that means all the proportional parts, okay, the smaller leg compared to the longer leg will have a proportional part of 2/5. The shorter leg, the other shorter leg compared to the longer leg will again have a proportional part of proportional constant of 2/5. So we can actually set up the proportion again in a very similar manner. We can say YZ to XZ is equal to YQ over XP. Or it's also equal to QZ to PZ. Okay? So, and all of this will be equal to 2/5. So knowing this, okay, and I already know what PZ is, and I already know what XP is, I can then use this to solve for the length of QZ and the length of PZ. I'm sorry, the length of QZ and the length of YQ. All right, so let's take a look. So I can see that YQ over XP is equal to 2/5. So XP, right, what's the length of XP? XP is 3. So therefore, I can solve for what YQ is. YQ, therefore, is equal to 1.2. Similarly, I can solve for what QZ is, okay? And how are we going to do that? Well, I know the length of PZ. PZ is equal to 5. So if I substitute 5 in, QZ is equal to 2. Now, again, we're going to be moving from point Z here because we found out what YQ is, okay? We found out what the length of QZ is. We need to move we need to go 1.2 to the left. I'm sorry, 2 to the left and 1.2 up, giving us a coordinate of 4, comma 3.2.